Resi, how to use it in OLX2. Here we go. Here's a structure where there are two ligands that are identical, and I can show this by Control, Shift, and a /. That hides all the bonds to the metal, and if I type much, then they will overlay. This is a useful trick to do anyway, to make sure that all the hydrogens are correctly placed. Fuse to go back, and Shift Control and / gets the bonds back. Okay, I hide them again and name this. So the command here I use is mode name -a = 10. And if I now click on any atom here, then this will find the longest. Oops, click on it, click carbon chain up to 7 and then make this 8. Escape key, and now I manually just go name 1. So this makes it F3 to toggle them on, and 1 and 2. And then exactly the same up key again, name 1, and then I have some fluorines at the top. Now that's all very well, but I haven't named this one, and this is where Resi comes in. All I need to do is I double click on this entity and I type Resi and give it a name, call it lig for ligand, and then minus all. That will find all the equivalent ones, and you noticed all the names have changed. And if I now change this into name F333, then this will be F333, and so will that be. So all the names take care of themselves, and I just go back to name F2 on this one here. Right, so all the names are the same, but not only that, if I put any restraints on this, then that will also works. So let's do a really silly restraint, and I'm clicking on that bond, and the command for the restraint is defix. Let's make it silly, 1.7, make it strongly silly, 0.01, and then -i. So this -i will apply this to this particular Resi, and this is now going to be done on the ligand. And if I refine this, then you will see that this bond here will become long. Now this isn't refining, and I suspect this is using OLX2 Refine, the new version of OLX2 Refine, which knows about this, but Resi doesn't work at the moment. So this is the development of the 1.3 version. This will be fixed as soon as it's released. I'll go back to Shell XL and refine this. And you should see the bond has become long, but not only here, but also here. So this restraint has been taken on both sides. And if I go Control M to show the map, then of course you see nicely that this is a completely silly restraint, and you shouldn't do that. The R factor has gone up, although some people would argue this is a respectable R factor, so therefore this is true. It's not true. So this is clearly a very silly restraint. And the only way to get rid of restraints at the moment is click up here and get rid of that restraint manually. And if you refine this, then things will go back to normal, and the R factor will be very much better. Okay, Shift and / to get those back. And now we can also use Control J. If you've got Report Plus installed, Draw Plus installed, it's over here in Work and in Draw. And we can scroll down, and I have the polyeder here. My transparency has gone lost, so if that happens, we need to click on this, graphics, and you can't see this. I'm going graphics, draw style, and I'm going to change the polyeder transparency to on. And now you can use the those keys here and make it darker and lighter, and or switch it off. So this gives you various visual styles for the for showing this particular complex. And if you, for example, go something like cell $N, we can select all nitrogens, and if you go label, you will get label. You will get the labels. And F3 to switch those working labels off. You can now use the Shift and the left mouse to move these labels into a sensible positions. And I'm not making a good job of this, but that's not the point of this particular video. So here we go. So this is N2 and 1. So this is we know that they're the equivalent ones. You could do something like hijack somebody else's label. I sometimes do that. So you can select that and type label. And we have silly labels we don't actually want, but I can click on this and call it Resi 2 and then I can place that label here, and I double click on that one here and call it Resi 1. And then you have the Resi 1 here. So this is one way of showing, or you can put it in the ring, but whatever, you know what I mean. I just type clear to clear the background here. So this gives you an image that makes it clear this is ligand number 1, this is ligand number 2. Of course, you could double click on the whole thing. Okay, we've got the bonds showing, so shift control and / I can click on Resi 2, and using draw plus I could group it to make it look like this. I can change the grouping, make it blended to 50 maybe, and then you will see it sort of shows like this. Yeah, various ways of getting different display styles here for your molecule. Right, the other way of doing it, of course, is I'm going to do this again, right click and ungroup. The other way, of course, you can do this, double click on one of the labels, Control A, delete. That deletes all the labels. And I could just have gone into the labeling thing. So let's say label all heteroatoms. So what that does automatically, it puts the Resi instruction in. You can now delete the labels you don't want. I haven't actually found a way to disable this particular underscore here, but in a way that's kind of maybe what you want in this particular case. If you want to show the Resi directly with the atom. So just to do this very quickly, I select all these labels I don't want, and come on, select all the labels I don't want and delete. And now I'm basically at the same image I had before, but I have the Resi explicitly displayed with the atom label. Well, I hope this was useful. This is how you use Resi. It is, I think, a very useful technique, and it can save a lot of time. In this case with 2 ligands, maybe not so much, but if you've got something with I don't know, 4 ligands and Z prime equals 4, you have a handful to do, and this way you make sure that it's all consistently labeled, and you can be sure that N1 and N1 and N1 in one Resi and N1 in the other Resi are actually equivalent nitrogen atom, which is ultimately what you want. Thanks for using ORDX2.